The process of extracting gold metal from gold ore and turning it into pure gold that is impure-free is known as gold refining. For generations, gold has been a highly desired and valuable metal. It is a symbol of luxury and fortune due to its rarity along beauty. A rigorous procedure is used to produce pure gold bars of the highest standard. Making 99.99% pure gold bars to a very high standard requires a number of laborious stages. First, superior gold ore is collected from the soil by mining. After that, the ore is put through a number of chemical, crushing, and grinding procedures to extract the gold from the other impurities. After being thoroughly refined to remove any last traces of impurity, the refined gold is melted down before being formed into bars. Let's investigate the interesting world of producing gold bars. You'll need some basic tools and supplies to get your gold bar production started. Crucibles, a furnace or kiln, flux, tongs, a graphite mold, a torch, safety equipment such as goggles as well as heat-resistant gloves, and gold are a few examples of these. Depending on the purity of the gold that was mined, either high-temperature heating or chemical exposure is used to purify the gold. First, processing of various ore types. If the ore contains low-grade gold, it is crushed into little pieces and placed in pads that have been thoroughly lined. The gold is then dissolved by treating the pads with a diluted cyanide solution. The metal in high-grade ore is ground into a powder in a grinding mill. Refractory ore is heated to temperatures over 1,000 degrees Fahrenheit in order to eliminate carbon and sulfide. The leaching circuit receives the resultant oxide ore. After being oxidized in an autoclave to separate gold from sulfide minerals, carbon-free sulfide refractory ore is sent to the leaching circuit. To create gold bars, many refining techniques are employed. Some of the often utilized refining techniques for creating gold bars are the electrolyte process, chemical treatment, smelting, and cupellation. You may smelt pure gold using any of these techniques. Process of electrolytes. The electrolyte procedure is intended for final users who require pure gold. An electrode known as an anode is formed by melting and casting 99.95% pure gold. An electrolyte solution containing cathodes composed of pure gold is added to the anode. Current flows through the electrolyte solution from the anode to the cathode when an electric current is applied between the electrodes. During this process, the anodes disintegrate and deposit themselves onto the cathode impurity-free. It takes a while to complete, but the result is 9,999 pure gold that can be melted and formed into bars. Chemical treatment. Chemical refining of gold is another widely used technique. Acids like hydrochloric, nitric, or sulfuric are used for treating gold. The chemicals react with the pollutants in the gold rather than with the actual gold. The impurities in gold can be melted away by the acids. After being separated, pure gold is melted and formed into bars. A high-quality final gold product is guaranteed by this technique. Smelting gold ore. Another method for refining gold ore is to use borax, soda ash, and silica. To create a dried precipitate, these substances are combined with gold ore and heated in a blast furnace. Slag that rises to the top of the mixture as the ore melts contains impurities that have been pulled from the gold ore. Due to its greater density, the molten gold sinks to the bottom. The pure gold can be extracted from beneath the slag as the smelted ore cools, leaving the slag on top. After that, the little gold button can be melted in a furnace and moved into a bar mold to create gold molds. How to make gold pure. The purity of gold affects its value in its completion. Gold can be purified using a number of helpful techniques, including cupellation, the Miller process, the Wohlwill process, and acid treatment. So here we take a look at some of the methods of purifying gold. The Miller method. Gold can be purified with chlorine, which creates chlorides with silver and other ore impurities, but does not damage gold. The refiner loads the ore into clay pots, fires up a furnace to heat the containers, and fills each pot with chlorine gas. The refiner recovers the pots and skims out the molten chlorides after the gold has been heated for a few hours, leaving behind 99.6 to 99.7% pure gold. Wohlwill process. Dr. Emil Wohlwill of the Norddeutsche Affinerie in Hamburg, Germany, created an electrolysis process in 1874 to purify gold. A 100-ounce anode made of unpurified gold ore is used, whereas the cathode is composed of pure gold strips. Hydrochloric acid and gold chloride make up the electrolyte solution. The gold at the anode dissolves and gathers at the cathode when a current of electricity flows through the electrolyte from the anode to the cathode. The cathode is melted at the refinery and formed into bars with a minimum purity of 99.5%. Cupation methods. Small amounts of ore can be separated from gold using the cupellation method. The ore is ground into a fine powder by the refiner, who then combines it with lead oxide, a flux consisting of borax or sand, and an organic reducing agent like flour or graphite. In a crucible, heating the mixture causes the lead oxide to decrease to lead, which then dissolves the gold to form a heavy molten phase. The phase is drained by the refiner and transferred into a second porous crucible from the bottom of the previous one. Lead, when heated, oxidizes, melts, and sinks into the walls of the crucible, releasing gold and other precious metals like silver and platinum. Acid therapy. Gold can be dissolved and used to purify scrap alloy containing gold by using the acid mixture known as aqua regia, or royal water. 3 parts hydrochloric acid to 1 part nitric acid is the mixture that makes up aqua regia. Gold chloride is created when the scrap gold dissolves. There may also be silver and platinum chlorides. The refiner uses butyl dig lime to separate the dissolved gold from the remainder of the dissolved precious metals after filtering out the undissolved material. The other noble metals are rejected by this odorless clear liquid, but it can store dissolved gold chloride. Similar to how vinegar separates from oil, butyl dig lime lies atop the aqua regia and can be skimmed off to get 99.9% pure gold. You can make your own distinctive gold bars by knowing how gold is refined, assembling the required tools, and adhering to the detailed instructions. Prioritize safety above everything else, take preventative measures, and carry out additional studies before starting this work. You will be disappointed if you hold a rock above a flame hot enough to melt gold and expect the gold to pour down. In reality, rocks cannot melt gold. Gold extraction from ore is a multi-step process that has historically required the use of hazardous chemicals like mercury and cyanide. Modern extraction methods have removed the necessity for these compounds and greatly increased process safety. However, it's still too risky to try at home. You can gain a greater understanding and appreciation of this precious metal through the skill of producing gold bars, regardless of your interests in investing, collecting, or just admiring craftsmanship. We are headed to the end of this video. Thank you for being to the end of the video. Don't forget to like, share, subscribe, and tell us what you think about this video below in the comment section. Let's meet again with an interesting video.